Hello everyone. In this video, we are going to see the C and C++ program to implement the SRTF scheduling algorithm. So SRTF is shortest job remaining first, and the other name for this SRTF is SRTN, that is shortest job remaining next algorithm. So this program will work both for the same arrival times or the different arrival times. Okay, so let's start. So here we have taken this example of 4 processes to understand our program for SRTF. So we have the 4 processes with their arrival times and with their CPU burst time. And this is the Gantt chart for this set of processes. So before moving forward, let me tell you, to understand the program of the SRTF, you must understand that how this SRTF actually works. That means you should solve some of the numerical based on SRTF. So you can find the numericals in my operating system playlist. The link of that playlist is in the description below. So I recommend that you must watch those videos before understanding this program. So just to recall how SRTF works. So SRTF is a preemptive algorithm. That means if we are having 2 processes, let's say inside the ready queue, who have arrived at same time, let's say t equal to 0. And let's say this P2 has the burst time as 3 and P1 has the burst time as 5. So the process which is having the minimum CPU burst time till current point of time, that particular process will be selected. So out of 3 and 5, which is least, so P2 having the 3 CPU burst time, it is the least process. Okay, so this burst time is minimum, so P2 will be selected first and it will be running on the CPU. Now let's assume that P2 runs for 1 unit, that is it starts from t equal to 0 and it runs for t equal to 1. Now you can see we have a new process P3 that has arrived inside the ready queue. Let's say it arrived at t equal to 1 and it has burst time as 1. Okay, so at t equal to 1 we have a smaller process having the smaller burst time than this currently executing process P2. See, P2 was having the burst time as 3. So when it runs for 1 unit, then it will be 2 units left to run more on the CPU. But we are having the shortest process inside the ready queue, that is P3, which is having the burst time as 1. So according to this SRTF, which is a preemptive algorithm, this P3 will say to P2 that please you come inside the ready queue, I will run on the CPU. Why? Because SRTF is a preemptive algorithm. It will force P2 to come or to leave the CPU. Okay, so now P3 will run and P2 will go back to the ready queue. Okay, so this is meant by the preemptive algorithm. Okay, so this is how SRTF actually works. I hope you have recalled. If you have not recalled, please watch 2 videos on the SRTF. Okay, so according to SRTF, this Gantt chart is made. So you can see that at t equal to 0, only P1 is there. So P1 comes on the CPU and it runs for the 5 unit. Okay, because till 5 there is no such process which has arrived. Okay, so it will run for complete time, that is 5 unit, and at 5 it was completed. Okay, so here you can see that I have written the completion time also. At 5 this P1 was over, so we can say it is out of our consideration now. Now at 5 there is no such process which has arrived, so the process that has arrived, it is P2 and that has arrived at 8. So from 5 to 8 the CPU will remain idle. Okay, now at 8 there is only one process, okay, P2, so P2 will run. Now you can see the next process is going to be arrived at 9. So what you do, that you just run P2 for 1 unit, 8 to 9. Okay, so the remaining time is left 3. Okay, now at 9 P4 is there, P2 is also there because it has not completed. So out of 3 and 2, SRTF will say this 2 is smaller, so P2 will leave the CPU and P4 will start. So P4 will start and let's say it runs for 1 unit. At 10 we saw that now this is 1 unit left and P3 has also arrived. So now we have to check out of 3 1 1 which is lesser. So of course this 1 is lesser, but they are 2 times 1. So which should be picked? Now we have the same CPU burst time for P3 and P4. So according to SRTF, it says now compare based on the arrival time. So P4 will be taken. Okay, so P4 will be taken again and it will run for 1 unit more. So it will run for 11 units. So now P4 is over and now P4 will go outside our consideration. Okay, now at 11 how many processes are left? We can see P2 and P3 are there. So out of 3 and 1 which is smaller, this CPU burst is smaller. Okay, so P3 will run for 1 unit and after that it will be over. Okay, and at last we are left with P2, so it will run for 3 units. So at 15 all the processes are completed. So I have written the completion time, okay, the turnaround times, waiting time, and response time also, okay, so that we can check later on for our program. Okay, so for our program, this will be the input, the process number, arrival time, CPU burst time, okay, and these are the outputs that we want. We want the turnaround time, we want the waiting time, response time, throughput, CPU utilization, and we also want the averages of this turnaround time, waiting time, response time. Okay, so these are the output that our program should give to us. Now before moving forward, let me tell you, this is the code for the shortest job first, which is a non-preemptive algorithm. And this we have seen in the previous video, in which we discussed the program for the SJF. And I would recommend you that you please watch the video of the SJF program. Why? Because 90% of the code of the SRTF will be similar to the SJF only. There will be small change inside this if and else, okay, and the most of the code will be similar to the SJF. So in this video, I will be focusing more on those things which are actually different from the shortest job first for the SRTF, and other things I will give you just hint, and you can watch the video of the SJF so that this video is also not so much longer. Okay, you can watch the video of the SJF for the remaining. So now before moving forward, you know that in the shortest remaining time first also we have to input some of the information like number of process in the system, the arrival time of each process, and the CPU burst time of the each of the n processes that we will be entering. Okay, so the first question that I have is how we can group the information of a process. Now a process has many information. What are those information? So each process has like arrival time, burst time associated with it. Then we will compute the completion time, turnaround time, waiting time, response time. Okay, so all the process have these type of information associated with them. Okay, so how we can store the information, these information inside our program? So although the answer we have discussed in the previous video of the first come first serve program and the SJF, so there are actually two ways. One is the use separate arrays for storing the arrival time and CPU burst time in our coding. So we can use the separate array, arrival time and burst time, and the arrival time and burst time of each of the 0th process will be saved here. The burst time of the 1th process will be saved here, and arrival time will be saved here. Okay, and the same way we can take the arrays for storing the completion time, turnaround time, and so on. Okay, but there is another better way. What is that? We can use the structure. That means the PID, that is the process number or the process ID, arrival time, burst time, completion time, and all the information of the process we can group inside a structure. Okay, so that under a single name we can store a information of the process. Here we have to remember many names like arrival time, that is array AT, BT. Then we will have a separate array that is like CT, that is the completion time. But here we will have only one array, that is array of structure, PS 100. So we will be like accessing these element, for example, PS, then I dot AT. Okay, so any of the information of any process can be just accessed using a single name. So this is actually a better way. Okay, so we will be having array of structure, something like that. PS0 will contain all the information of the 0th process, PS1 will contain the information of the next process, and so on. So now let's see how we can input the data, or how we can input the arrival time and the burst time for given number of processes. So finally, this is our algorithm for the shortest remaining time first. Okay, so here you can see this code is mostly same as shortest job first, and this red color lines, they are different from the SJF. Okay, so this thing we will be focusing more in this video. Okay, so see, first point is we have to ask the user about the number of process, arrival time, and CPU burst time as the input for this program. Okay, and for this, what will be the code? So we can just scan this number of process using scanf in C program, or we can use the C inside the C++ program. For the arrival time and for the CPU burst time, what we can do? We can use loops to input these values. Okay, so here you can see we have used two for loops. This for loop is scanning the arrival time, and this for loop is scanning the CPU burst time. So here we have scanned the arrival time from I equal to 0 to I less than n. So here it will be PS of 0.80, PS of 1.80. So all the values will be going inside this arrival time field of various processes. Okay, and along with that, I have scanned, or I have initialized this PID variable also. Okay, so I'm saying, okay, PS0.PID, PS1.PID, they will be initialized with the I. So for I equal to 0, this PID will be 0. So this PID will be 0. For I equal to 1, this PID will be 1. That is PS of 1 dot PID will be 1. Okay. So these are the process ID numbers for the various processes. Now in this for loop, we are asking for the bus time. So the same way we are asking for the bus time inside this BT variable. Okay. PS0.BT, PS1.BT, so on. And here you can see inside this for loop, I have initialize the another array, that is BT underscore remaining. So this is the BT underscore remaining array. So what is this array? So this is a new array that we have taken outside the structure. Okay. And we are saying, okay, whatever bus time you are scanning for each of the process, just copy them inside the remaining array. Okay. So if you are taking, let's say, bus time as 3 of the first process or the 0th process, then copy it inside this BT underscore remaining at the 0th index. Let's say for the PS1, you said the CPU bus time is 5, then copy it inside this remaining array. So that means whatever value we are scanning inside this array of structure, we have to copy inside this BT underscore remaining. Now what is the need of this BT underscore remaining array? So we'll see in the later in the video. Okay. So let's come back to our algorithm. So after scanning the number of processes, arrival time and CPU bus time for each of the process, we have to do the processing so that we can print our required output. We have to print the turnaround time, completion time, waiting time, and their averages, CPU utilization, and so on. Okay. So what is the processing? So this is the processing part. Okay. Or you can say this is the main part. So again, this is the code similar to your SJF. Okay. So what we have done, we have taken two variables, completed and the current time. So completed variable will keep track of the number of process that has been completed at a particular point of time. So let's say at any point of time, out of these 4 processes, only 2 processes have been complete. Let's say P1 and P3. Then this completed variable will have the value as 2. Okay. Now this current time variable is keeping track of the time. Okay. So what is the time at a particular point of time that is initialized or that has been stored inside this current time. Okay. So this current time will be changing from 0, 1, 2 and so on. Now we have taken a while loop, and this while loop is starting from here, and then inside this while loop we have this line, then we have the if. So inside if again we have if. So this if is ending here, then this if outer if is ending here, then we have the else part. Okay, else part for this if. Okay, I have written here due to this space problem. Okay, then this else has only one line, and after this while loop. Okay, this while loop is ending here. Okay, so let's understand it. So this while loop is saying till the point all the processes are not completed, then you have to continue with all these processes or all these things, right? So completed value initially is 0, so it will be incremented somehow in the code. Here you can see it is getting incremented. So it will be 1, then 1 will not be equal to 4 because we have 4 processes. Then again we will come inside, then sometime completed will be 2 and so on. When completed will be equal to 4, then we will come out of this while loop. So as you know, this SRTF algorithm says that whichever process is having the minimum bus time, you have to take that process. And after some time, it may happen that a process may not complete fully. Okay, let's say P1 can complete just for 2 units of time, then 3 units will be left over. So it is like after that again we have to take decisions whether we have to take P1 or any other process. Okay, so this word remaining is important. Remaining means out of the remaining portion of the various processes for the CPU bus time, we have to take those parts into account. Now what does it mean? So let's see. So what we have done is, if you see here, we have taken a array BT underscore remaining, and I have told you that BT underscore remaining was initialized with the initial values of the bus time in the for loop that I mentioned previously, right? So actually we have taken another array BT underscore remaining, which will actually initially be equal to 5, 4, 1, 2. That is, it will be initialized with the bus time only. Okay, and we'll see what is the work of, and its work will be like, for example, P1 has completed, let's say, for 2 units of time, and after that it has to leave the CPU. Then how many bus time it has to complete in the future? So out of 5, if 2 are subtracted, then 3 will be left over. So then this 5 will be changed to 3. Okay, so Same way, let's say P2 comes to the CPU, and let's say 1 unit of the PPU, and similarly, let's say P2 is completed just for 1 unit of time. So how many CPU burst time will be left for this P2? So if 1 unit is subtracted, then 3 will be left over. So we will be changing this BT underscore remaining array to keep track of the remaining amount of the CPU burst time. We will not be changing this BT, okay? And this BT and BT underscore remaining will be checked somehow in the code, and we will be using both of the arrays, okay? So here you can see we are using the BT underscore remaining also, and PS min index.bt. We are using this array also and this array also. So let's proceed with the code. So it is saying, okay, initially completed is 0. 0 is not equal to 4. So come inside. Now this line is saying you have to find the process which is having the minimum CPU burst time till the current point of time. So currently we have the current time as 0. So till 0 point, or you can say if the clock is having the time as 0, so till 0, what is the process that has come inside the ready queue? So only P1 has arrived till the point or till the time 0, okay, which is having the burst time as 5. So this is the only process. So this will be the minimum only, right? So this code will be giving us P1. So actually this code will be giving us the indexes 0, 1, 2, 3. It will be giving us this 0 index of this array of structure, okay? So it will be giving us the index that is 0, okay? Now we will come inside this if, and we will be checking if we have found any process, then we will proceed forward. If we have not found any process inside the ready queue till current point of time, that means ready queue is empty, then we will come to else part only, and we will just increment the current time by step of 1, okay? So currently we have found the process. So we have found the process means we have found our index, okay? So it can be 0, 1, 2, 3. So currently it is 0. So now we will come inside, and this is the main part that we have to see. So in the SJF, it was like if any process is found, then we just compute all the matrices, okay? And we also find the sums, right? We say, okay, just add this completion time, turnaround time, WT and RT also, so that later on we can find the averages, okay? So, but here in the SRTF, we are not saying, okay, if the burst time is 5, just complete it completely on the CPU. We say, okay, if the burst time is 5, you have to increment in the step of 1, okay? You have to, you can say, increment the current time in the step of 1, because it can happen that a process is going to the CPU, but after just 1 unit of time of this P1, another process has arrived inside the ready queue which is having shorter CPU burst time. Then we have to select that process, because SRTF is a non-preempt, because SRTF is a preemptive algorithm, okay? So here you can see we are saying, okay, if we have found a process, just compare the actual burst time and the remaining burst time, okay, of that minimum index process, okay? Now you will say, what is this min index, okay? So actually from here we will get a min index variable having this 0 index, okay? So this is the actual variable which will be storing the index of the minimum CPU burst time process, okay? So here mindex, so here min index will equal to 0, and we will say, okay, come inside. Now we are checking for this particular process whether its actual CPU burst time and remaining burst time is equal or not. So currently both are equal. This is also 5 and this is also 5. So we will say, okay, if remaining time and the actual burst time, they are equal, it means this process, or you can say P1, has arrived for the first time on the CPU, okay? So we will come inside and we will say, okay, start this process. At what time? The current time is 0. So the start time for P1 will be 0. So if we draw the Gantt chart, we will say P1 has started at 0. So this is the start time, that is 0, okay? Now after that, what we will do, we will just say, okay, you just complete 1 unit of time on the CPU. So this is like BT underscore remaining, we are decrementing it by 1, okay? So we will say, okay, now you are 4, correct? So we have completed 1. Now we will increment the current time by 1, okay? So current time has now increased to 1. Now after this, there can be 2 situations. One situation is the current one, that is this bt underscore remaining is a non-zero value. We decremented it by 1, and again this is a non-zero value. 4 is a non-zero value. So that means the process P1 has not completed itself completely, right? But it can happen something like that. Let's say this current, but it can happen, let's say this actual burst time of the P1 is given to us as 1. And so we will copy inside bt underscore remaining initially as 1. Okay. Now when this P1 completed 1 unit of time, how much time will be left for this P1 in the future? It will be 0 in the bt underscore remaining. So currently bt underscore remaining is 0. So what does this indicate? It indicates that now P1 has completed its total CPU burst time on the CPU. Now it will not run in the future. Okay. So if a process has completed itself completely, then what should we do? Then we should compute its completion time, turnaround time, waiting time, round trip time. Then we should compute its completion time, turnaround time, waiting time, response time, and other thing. And we will say, okay, one process has been completed, right? But if this bt underscore remaining is not 0, then we cannot say, or we cannot compute these things. We will wait. So that situation is checked here. So we will say after decrementing by 1, if this remaining array has 0 value, so this is 4, so this is not equal to 0, so that means P1 has not completed. So we will simply skip this if, and then we will go back again to this while loop. Okay, and again completed is 0 only. Okay, no process has completed. Again we will come and we will say, okay, find the process having the minimum CPU burst time from the ready queue till current point of time. So currently time has increased to 1. So till 1, is there any process that has arrived inside the ready queue? No. No new process has arrived, only P1 is there. So now again P1 will run on the CPU because there is no any other process, because this is the only minimum process having the burst time remaining as 4. So again we will run. Okay, so P1 will again run and we will run it for 1 unit. Okay, so here you can see we just selected P1, we come inside and we say, okay, such process is found having the index 0. Then we matched the remaining and the actual burst time. So remaining is 4 and actual is 5. So this both will be not matched. So this if will be false. Okay, and this is also correct because we will not initialize this start time again and again. Okay, so we will skip this if and we will just decrement the remaining time by 1. So it will be now 3, and then we will say current time is 2. So current time is 2, and then we will say, okay, if that process has been completed, okay, this remaining time is 3. It is not equal to 0. Okay, so we will leave this thing. Okay, and then again we will start. Okay, and we will say again, okay, completed is not equal to 4. So again find the minimum CPU burst time process. Okay, so you will see that the new process has arrived at 8, right? This has arrived at 8. So till 8 there will be no new process and this P1 will complete itself fully. Okay, so actually this loop will go on till 5 as such. Okay, so it will be P1 so on, so 2 3 4 5. Okay, till 5 it will be the same condition. So we will have the current time as 5. Okay, and you can say this is 5. Okay, and after it completes itself fully 0 to 5, this remaining will be 0. So at 5 it will come inside again. This will not be true, so we will decrement. Now after decrementing it was made 0. We will say current time 5. Okay, now we will say, okay, this has made 0. So bt underscore remaining is 0. Yes, so we will compute everything. We will calculate completion time and all things. So completion time will be equal to 5. So we will initialize it with the help of current time. And then with the help of completion time, we are calculating turnaround time. Turnaround time is helping us to calculate waiting time. And then we are calculating the response time. Okay, so here you can see for P1, what is the response time? So it arrived at 0 and it got the CPU at 0. So here we are saying, okay, just say start time minus arrival time. So what is the start time for P1? It is 0. And what is the arrival time? It is 0. So 0 minus 0, 0. Okay, and then we will compute the sum that we have computed inside the SGF also. Okay, we will just add this thing. turnaround time, waiting time, response time in their 3 separate variables. And after that, we will say one process has been completed, that is P1. So completed will be incremented to 1. And after that, we will say is completed for that process equal to true. So again, this is a new array, okay, is completed. So I will write here is completed status, okay. So you can see this is a is completed status. It is initially 0, okay. So this is telling me that which process has been completed completely, okay. So this was also used in the SGF also, okay. So now P1 is completed, so it will be 1, or you can say it will be true, okay. True means 1. Now we will again go to this loop, and now we will say that completed is 1. 1 is not equal to 4. Again, we will find the minimum CPU burst time from the remaining processes till the current point of time. So at 5, is there any process that has arrived? So actually there is no process that has arrived, right? So you can see at 8 only new process will arrive. So actually what will happen? It will say no, okay, there is no process. So actually min index will be given to us as -1 whenever there will be no process inside the ready queue, or ready queue will be empty. At that point, min index will be -1. That we will see later in the code, okay. So at that time we will say, okay, if min index is -1, then we will say, okay, there is no such process found inside the ready queue. We'll leave this if and we'll come to else. We will increment this current time in that case by 1 only, okay. So we'll say, okay, just increment it by 1, okay. And you know that again we will go, again we'll find the new process. There will be no new process till 6, right? Because current time has increased to 6. So till 6 there is no new process. So again we'll come to else, and this process will keep on, that this will be incremented till 8, okay. And this part will be called as idle time, okay. CPU was idle. So when time was incremented to 8, there was no new process arrived, okay. Now at 8 new process will arrive. So again we will come inside, and at 8 what is the new process that has arrived? Only P2. So this will be the only process that we will be selecting. So index will be given to us as 1, okay, inside min index. We have found the process. Now again we'll say, okay, this has arrived for the first time, so this will be true, okay. And then we'll set its start time to what? We'll say start time will be equal to 8, that is current time, right? So now P2 will start, right? And then we will decrement its remaining time by 1, increase the current time, decrement it by 1, and then current time will be now 9. Then we'll say, is that process has been completed by checking its remaining array, okay. No, it has not been completed. So again go, okay. Now we will again go back and we'll see, okay, current time is 9, till time which process has arrived? So we'll say P4 has arrived, okay. So out of 3 and 2, which is the minimum CPU burst time? We'll say this 2, right? So this code will be giving us the index 3, okay. Now for 3, these both are equal. So we'll say set the start time of this process P4, okay. So after P2 we will run P4, okay, and we'll say, okay, the start time will be 9. After this, decrement the remaining time, that is this will be 1, and current time will be now 10. Current time will be 10, and we'll say this process has been completed. Remaining time is 0. No. So we'll leave this if and we'll go again. And now again we'll say, okay, till 10, what are the minimum process having the minimum CPU burst time, you can say? So we'll say 3, 1, 1, and out of this 1 is the minimum. But we are having 2 processes having the same burst time and both are minimum. So which should be selected? We should be selecting now the process based on the arrival time. Whichever process has come earlier, okay, we will be selecting that one. So we will be selecting P4 because its arrival time is 9. So again this code should give us this 3, okay. So now again we'll see, okay, both are equal. No, do not set the start time, just decrement remaining time, increment current time. So P4 will again run, the current time will be 11, okay. This will be made 0, remaining time will be made 0. Now we will say, okay, remaining has become 0. Yes, remaining has become 0. So we will compute all the current time, completion time, turnaround time, and so on, okay. So you can see the response time, it will be like start time of this P4 was what? Not 10, it was 9. Okay, it was set just at this point when both were equal. So it was 9. And what is the arrival time of this P4? The arrival time is 9. Okay, so 9 minus 9, what is that? 0. Okay, so this process arrived at 9 and it got the CPU at 9 only. That's why its response time is coming as 0. Okay, now we will compute other things, sum, and then we will say completed has become 2 because 2 process has been completed, P1 and P4. So we are crossing. Now we will say this process has completed, so we'll mark this as true. Okay, now again we'll go and we'll select the minimum process till current time or the process which is having the minimum CPU burst time. So till 11, no new process arrived. We will be selecting out of P2 and P3. Okay, so out of 3 and 1, we will be selecting this P3. Okay, so this will be giving us the index 2. Okay, again for the P3, we are starting for the first time. So both are equal. Both are equal. We'll set the start time as 11, and then we will be decrementing its remaining time. So it will be 0. Current time is increased. It will be 12. It will be 12. And finally, we'll say this process has completed. So we'll compute its completion time, turnaround time, and so on. Okay. So here you can see I have written all the completion time 5, 15, 12, 11. So see at 12, this P3 has completed, right? So I'll just write 1 here. Okay. And now after completing everything, we'll say again completed is incremented. So 3 process has been completed. This P3 has been completed. Okay. And current time is 12. Okay. And is completed for this particular process, that is index number 2, it will be 1. Okay, this is 1. So this is 1, this is 1, this is 1. Okay, so now we'll go again and we'll say find the minimum process till 12. So only this process has been remained. Okay, so this 3 will be selected at the minimum CPU burst time. So this will be giving us 1. And for 1 again, we'll say this is false. So we'll decrement it. And then current time is increased. Okay, and so on. So here you can see because after P2 there is no new process, so it will run on the CPU only. Okay, so it will complete. It's now time for the 3 units, right? So this will decrement it by 1 by 1, but you can say this will be now 2. Okay, current time will be 13, and then we'll go again. So it will be like here P2 will be there. Okay, so I will write P2 here 13. Okay, then again will come again this process P2 will be selected, right? That is index number 1. Then we'll decrement it by 1, so on. So at particular point of time, what it will be 13. I'm writing it here 13 to 14 P2. Okay, then it will be 1, and at last that is at 14 again we will come here. We'll say okay, P2 will run for 15. Okay, and after 15, this current time will be 15, this will be made 0. Okay, and at that 15 time, we'll say this index has become 0. Okay, or you can say this remaining time has become 0. So we'll compute everything for the P2 also. Okay, so you can say completion time of P2 is 15. So this way, all the completed will become 4. Okay, so we'll say now this 4 is not equal to 4, wrong. So we'll come out of else, and then we will print everything. Okay, so this way I hope you have understood that how this code is working. Okay, so this was the main part. We are just incrementing the current time in step of 1. We are decrementing in step of 1, and at each step we are saying okay, if this process has been completed or not. If completed, compute everything, otherwise just go again back. Okay, and we are again checking in from the remaining time. The minimum time is selected from the remaining time, not from the actual time. So now let's move forward and see what is the code for this part, that how we are selecting the minimum CPU burst time process. So this is the code to find the process with the minimum CPU burst time. Okay, so here the code is actually same as we have seen in the SJF. Just one change is there. In place of BT underscore remaining, in SJF we use the BT array, that is the actual array burst time. The same psi.bt we used here. But in SJF, we are checking with respect to our remaining array. Okay, so you know that we are using the remaining array also, right? Let's say this was completed, so remaining array will have 0. Let's say P2 gets 1 unit only and its remaining array has 3. Let's say P4 has 1. So when we are coming, let's say here and we want to select the process with the minimum CPU burst time, then we will be seeing not this 5412, we will be seeing 0311, right? Till the current point of time we will be selecting, or we will be checking with respect to our remaining array. Okay, we have to see, okay, out of this remaining time, okay, which can be selected, which has the minimum CPU burst time. So that's thing we are checking here, okay, because it is a non-preemptive, because SRTF is a non-preemptive algorithm, so it may not happen that a particular process is completed fully. Okay, so we have to check from the remaining. Okay, so this is just the change with respect to our SJF. Otherwise, all the explanation is similar to what we have discussed in the SJF. So you can go to the SJF program video and you can see this part and you can understand the explanation from here. So I'm not explaining that part again here because video will be longer. Okay, so now let's move forward and find the CPU utilization. Okay, so CPU utilization or the CPU utilization percentage have the formula like length of the total cycle minus the CPU idle time. It will give us the actual CPU utilization time divided by total completion cycle length. So let's first compute the total CPU idle time. So I have taken two variables, one is boolean variable, one is integer. So each first process is a boolean variable which will be storing true or false. So it will be just be telling me, am I the first process to come inside this while loop or not? Okay, and this previous is storing the completion time, or you can say the previous time of the process. For example, let's say we are at P4. So before that, P2 has just partially completed at 9. So at P4, if you want to see previous value, okay, this variable value, it will be storing 9. Let's say we are at P3 and we want to see what is the value stored inside previous, it will be 11. Okay, so this is the value that is stored inside the previous variable. So let's see how we are using this. Okay, so here you can see inside the while loop, here I have written the code for the minimum CPU burst time. Okay, although I have not shown here to reduce the space. Okay, so I will first select P1 as previous and then we will say, okay, this is the first process. So we will do now these two things. We'll say set the start time as 0. Okay, and then we'll in the idle time we'll add 0. How? We'll say is first process is true. It is true. So we'll say true equal to true. Yes. So 0 will go inside this total idle time. The total idle time will be equal to 0. Now after that we will just decrement it. Okay, and we are saying the previous will be storing this 1. Okay, the 1. Then we'll go again and so on at 5. Okay, at 5 what will happen? This previous will store the 5. Okay, at current time 5 we will be storing this previous equal to 5. Okay, so when current time is 5, this previous is storing 5, this will be become 0. We will compute everything. Okay, and now we will go again. Okay, and now new process will become selected, but at 5 there was no process. So what will happen? Now we have to actually compute this idle time. How we will computing? So at 8 only new process has arrived. So we will be just going and we will be incrementing the current time as we have shown earlier. Okay, at 8 it will be selected. So at 8 we will be coming inside. Okay, and we'll say, okay, this 4 is equal to remaining time, because 4 will be equal to 4. Here we have the remaining array, right? It was made 0. Okay, so this is equal. So we'll come here and we'll say set the time of this, you can say this P2 as 8. Okay, so this start time is 8. Now we'll say idle time. So we'll say, okay, now when you will come here, what will be the value stored inside the previous main thing? Okay, start time we know, start time is just 8. Okay, and I'm saying this previous will be storing 5, and you can just check that previous will be storing 5. Why? Because in this line we will not be coming in this space. Okay, when the previous was storing 5, after that we will not come here. Why? Because there was no such process found. We was coming to else. So previous was storing 5 at the last time. Okay, so 8 minus 5 it will be 3. So currently 3 will be added to this total idle time. Okay, so we have added this one. Okay, now we'll come here and then we'll do the rest of the things, and then we'll increment this current time. We'll be making it 9. Okay, and now after that you can run it yourself, and then you will see that now idle time will remain as 0. Okay, idle time will be added to 0 only, this thing. Okay, so at last, when we'll see the value of the total idle time, finally, after this while loop is over, we'll say 3 is stored here. Okay, so you can run this by yourself. I have just given you the hint. Okay, now let's see how we can compute the total length of the cycle, because for this equalization we need that thing also. So to find this length of the completion cycle, that is, we want that what is the length of this one. So 15 minus 0 is 15, this total time, right? So for this, what we want the completion time of the last completed process and the arrival time of the first process. Okay, and why we need to know the arrival time of the first process, we can just check from here only. It is because it may happen that P2 will be the first process. That means it may have arrived at 0 and P1 its time given to us as 1. So because we are not applying any you can say sorting and all, this will be indexed 0, 1, 2, 3. So we cannot say at 0th index my first process is kept. Okay, it will not be always true. So we have to apply some logic to find the arrival time of the first process, okay, and the completion time of the last completed process. So what we have done, we have taken two variables, maximum completion time, minimum arrival time. So there will be, you can say, two variables which will be storing the maximum completion time. It will be 15 and last it will be 0. Okay, so here you can see, like you can use the concept of the finding the maximum in the array and minimum in the array. So this ps I dot completion, so this completion is like this array. Okay, so from this array, and you are selecting the maximum completion time. So maximum completion time is this 15. Okay, so you can apply this by yourself. This is the function that is finding the maximum completion. Okay, so same way we are finding the minimum arrival time, okay, from this array. Okay, and this minimum arrival time variable will be storing the minimum arrival time. So finally we will be subtracting this completion time minus minimum arrival time to find the length of the cycle. Okay, and then we will be using this formula to find the CPU fraction. Okay, so now let's see the throughput. So throughput is total number of processes divided by total length of the cycle, number of process completed per unit time. So total we have the 4 processes and length of the cycle was 15 minus 0. So it will be 4 upon 15. Okay, so this way you can compute the throughput. So I hope you have understood the code and what are the differences in the SRTF and the SJF code. Okay, so now let's move to the C program implementation for this SRTF. So here you can see inside the C program we have added the required header files first, then this is the structure. Now after that we have the main function. Inside that we have defined the required variables. We have scanned the total number of process. Then inside two for loops we have scanned the arrival time, IDs, bus time, and the initialize the remaining array, right? And now you can see that we have the while loop. Inside while loop we are finding the process with the minimum CPU bus time, okay, from the remaining array. So here you can see we have the minimum index as -1 and minimum variable which is storing the minimum CPU bus time, okay, actual CPU minimum, and the minimum variable which is storing the minimum bus time. It is initialized with int maximum, okay, and then we are finding the that particular required process with the minimum bus time. The index of that is found. If that index is -1, that means no process is found, okay, and if process is found, we are doing the same thing that we have discussed. Okay, we are doing everything, start time, initialization, idle time, and so on. And after computing everything, completion, turnaround time, waiting time, when the process is completed, okay, finally we are coming here, okay, and this line will not be there actually. After saying everything completed plus plus and is completed array is equal to true. Okay, so here you can see is completed array, okay, is completed array is actually a boolean array which is initially false. Okay, so now here you can see that after this while loop is over, we are finding the length of the completion time. Okay, so here you can see we have used the find max and find min. Okay, two variables, we are finding the maximum and minimum. So in C we have written the code by ourselves to find the minimum between the two variables. Okay, and now after computing this cycle length, we can just print the outputs, that is the various completion time, turnaround time in the tabular form. Okay, and finally we have computed the CPU utilization, throughput, and everything, that is the averages of all the turnaround time and everything. Okay, so here you can see some turnaround time, some waiting time. Where are they computed? So they are computed inside this while loop, right? Okay, every time we are completing one process, we are computing, or we are taking that turnaround time, waiting time, and we are adding with their respective variables. Okay, so here total sum is calculated, and finally we are calculating the averages. Okay, throughput is there, and this is the CPU utilization. So now let's run this program and see what is the output. So I'll run for the same example that we have discussed. So arrival time will start with from 0, then 8, then 10, then 9. Then bus time is 5, 4, 1. So here is our average turnaround time, waiting time, response time. Throughput is 0.2666. CPU utilization is 80.00. Right? So these are the tabular forms. Okay, the completion time, turnaround time, all are in the tabular form for the better interactivity. Right? So you can just check or cross verify with the example that we have shown just before. Okay, so you can run for the other examples and you can verify your answer. Now see the C++ program. Okay, so here you can see this is the C++ program, just some changes in the header file. Okay, and here you can see we have used the algorithm header file. So this header file is used so that we can use the maximum and minimum function. Okay, so we'll see later. Okay, so again everything is same. Okay, there is no as such change. We have the same structure. Okay, we have the same, you can say, total number of processes are scanned, arrival time. Okay, and you can say bus time, everything is scanned as such. Okay, now we want to print all these outputs till 2 decimal places. So in the C++ program I am using this set precision. Okay, this is inside the IO menu header file, and I am saying till 2 decimal places I want to print. Okay, if I do not use this one, then I will get the same answer as I was getting in the C program. Okay, so I have just used for this thing, and after that the same while loop. Okay, everything is same. Okay, nothing is changed. You can just check it later. And here I have used the maximum and minimum. So these functions are present inside your algorithm header file. Okay, that's why I have used that one, and I have not written the code for this. It is implicitly written inside the C++. And after that everything is same. Okay, so I'm not running this example. You can just check it yourself. I will provide the link of this program C and C++ in the video description below as the GitHub link. You can check there. So I hope you have understood both of the code and how this SRTF works. So if you have any doubt, please write down into the comment box, and if you like the video, please share and like this video and subscribe to the channel and press the bell icon for further notification of the videos. See you in the next video with next program, that is round robin. Till then, bye.